decade for the 1990s space station freedom.
As we move further into the 21st century, aviation is looking towards new horizons. Who knows where tomorrow's destinations will be? Futurists have long envisaged settlements on the moon and regular flights outside Earth's atmosphere for pleasure as well as scientific research. In 1982, the US government initiated a top-secret research program known as Copper Canyon to investigate the feasibility of a single-stage-to-orbit aeroplane which could take off and land horizontally. The program then evolved into what President Ronald Reagan described as a new Orient Express that could, by the end of the next decade, take off from Dulles Airport and accelerate up to 25 times the speed of sound, attaining low Earth orbit or flying to Tokyo within 2 hours. In 1990, MacDonald Douglas, Rockwell International and General Dynamics joined forces to develop the X-30 National Aero-Space Plane, or NASP. The plan was to use active thermal management to generate higher speeds than the Mach 8 achieved through conventional technology. The jet's hydrogen propellant was circulated through the aircraft's skin before being injected into the engine, heating the vehicle and generating energy through atmospheric drag to increase thrust and push the jet through the Mach 8 thermal barrier. Some scientists even believed that active thermal management could generate speeds of up to Mach 25, using Scramjet air-breathing engines rather than rocket propellant. At the time, Scramjet technology had never been tested, but it has since gone on to become the leading edge in atmospheric engine development. It is based on the same concept as the ramjet, where air enters the jet engine so fast it does not require turbines and blades to compress the air to a usable pressure. The supersonic combustion ramjet Scramjet is seen as a possible low-cost method of reaching low Earth orbit or high-speed intercontinental transportation. Unlike rocket engines that need to carry oxidizer as well as fuel to burn, the Scramjet gets its oxygen from the very thin upper atmosphere. Operating at speeds beginning at Mach 5, it can achieve near orbital speeds. Operating at such high altitudes, designers expected the X-plane to be exposed to temperatures exceeding 1,650 degrees Celsius on the leading edges and parts of the engine. The rest of the plane's surface would need to tolerate temperatures of up to 980 degrees Celsius. The project team worked on developing high-temperature, lightweight materials such as alloys of titanium and aluminium called alpha titanium aluminide, advanced carbon and carbon composites, and titanium metal matrix composite with silicon carbide fibers. Although the project progressed well and achieved some technological breakthroughs, it faced significant constraints. Among them was the Department of Defense specification that the aircraft carry a crew of 2 as well as a payload. Achieving the level of safety required for a man-rated vehicle proved too difficult, and the project was cancelled in 1993. However, the dream of space passenger travel refused to die.
For every one that says you couldn't pay me enough to go, there are 10 that are out there that say, I'll give you everything I've got, just let me go on the rocket. And the other thing they want to know is, well, when is NASA going to put a bunch of seats in the back of the space shuttle, big windows back in the cargo bay, and when are you going to start carrying passengers? And I always have to answer them, well, I'm afraid we are probably never going to do that.
Space enthusiasts were still speculating about the ultimate trip, a ride on a suborbital flight booked through your local travel agency. US company Space Adventures dreamed of developing a spacecraft capable of carrying passengers to astronaut altitude. As the 1990s progressed, non-government players like Space Adventures moved into the space research market with the philosophy that the best way to expand mankind's reach into space was through commercialization and, above all, tourism. With tens of thousands of space enthusiasts around the world, entrepreneurs bet that paying customers would be the backbone of future expansion into space. This became the basis of the X Prize competition. Modeled on the aviation prizes of a century ago, the X Prize set a challenge to anyone who could meet certain criteria. The prize was open to any non-government group or industry that could launch a piloted vehicle to the edge of space, defined as 100 kilometers in altitude, return safely to Earth, and do it again within 2 weeks. 26 teams from around the world developed wide-ranging technology to take part in the competition. They came from countries such as Canada, Romania, the United Kingdom, and Russia. In September 2004, one of the Romanian teams launched a demonstrator 2B rocket from a launch pad at a military base near the Black Sea. The rocket was powered by hydrogen peroxide fuel. This is a completely non-government project. The financing is exclusively from private sources and through the financial efforts of the members of the team. First of all, we are motivated to continue with this project because we want to represent Romania in the X Prize competition, and later in the X Prize Cup starting next year in New Mexico. First set up in 1996, the X Prize changed its name to the Ansari X Prize after a multi-million-dollar prize injection by Iranian-American space tourist Anousheh Ansari, who traveled to the International Space Station in 2006. This vehicle is a prototype called the Demonstrator 2B. It's a prototype for a vehicle named Horizon, whose construction has started already. A vehicle capable of fulfilling all the requirements of the X Prize competition. We hope that this vehicle will get its first flight at the beginning of next year. The Demonstrator 2B made a successful flight and entered the competition. But like the other competitors, it was eventually eclipsed by the brainchild of an American visionary. An Oregon-born aerospace engineer, Burt Rutan, learned his craft with the U.S. Air Force. He was stationed at Edwards Air Force Base as a flight test project engineer from 1965 to 1972, and went on to become the director of the Bead Test Center for Bead aircraft. In 1974, he founded the Rutan Aircraft Factory and then Scaled Composites, an aircraft design and prototype facility. But his gaze was firmly fixed on the stars.
The new private space entrepreneurs have a vision. I'm one of them. We do want our children to go to the planets. We are willing to seek breakthroughs by taking risks. And if the business as usual space developers continue their decades-long pace, they will be gazing from the slow lane as we speed into the new space age.
And this dream started to become a reality in September 2004, when Mike Melville piloted the Rutan-designed Spaceship One on a successful flight into space.
Well, I'm very, very flattered to have been chosen for this. The other two guys are every bit as good as me or better. And I just got the short straw or the long straw, whatever it is, and I'm delighted to do it. I enjoyed the last flight. I'm hoping this will be an exact repetition, just a little tall, a little higher, a little faster. And I'm looking forward to it very, very much. And I'm ready to go, boy. I am ready to go, and we are going to win the X Prize. Put your money on it.
Onlookers flocked to the California desert to watch the spacecraft take off in its quest to win the X Prize. Largely funded by Microsoft billionaire Paul Allen, the white rocket plane cost $25 million to develop and became the first privately funded aircraft to exceed Mach 2 and Mach 3, the first to fly higher than 100 kilometers, and the first privately funded reusable manned spacecraft. The experimental air-launched suborbital spaceplane was powered by a hybrid rocket motor and featured a unique feathering atmospheric re-entry system. Those gathering in the Mojave Desert were excited to witness history in the making.
Well, I'm hoping to see a little bit of a private space flight.
Why is that important?
I think that's important. I think that we need to be reminded that it's people who do things, not the state.
It's first, it's history, we're here, it's exciting, we're pioneers, it's neat, it's different.
History is, being made. It's just like out here, 40, 50 years ago when Jaeger was the first one to break the sound barrier. People came out to see that. So that's something I can set the grandkids on my knee and say, hey, we were there.
A larger aircraft called the White Knight carried Spaceship One to 50,000 feet, then launched it towards space. The spacecraft burned its rocket for 80 seconds to reach its peak altitude, where Melville became the first commercial astronaut and experienced weightlessness. Looking out of the window, he could see the black expanse of space, while below was the soft blue curve of the Earth's rim. The spacecraft easily surpassed the 100-kilometer altitude required by the X Prize contest rules. It peaked beyond the atmosphere before booming back towards the desert at Mach 3, entering a long, slow spiral glide toward landing, accompanied by 3 chase planes. The craft returned to its hangar with no damage, and Melville described the experience as a comfortable, easy flight, despite a series of vertical rolls that had spectators on the ground holding their breath. Melville downplayed the dramatic maneuvers and said he was able to slow the rolling from about 1 revolution every 2 seconds to a standstill by the time he entered space, using onboard controls.
Okay, the flight was spectacular, it really was. The view from up there, I was so sad that Bert and Paul couldn't be with me, because looking out of the window and seeing this white clouds over the LA basin just looked like snow on the ground. And Edwards Air Force Base lake looked about that big. And I know I was 330 or something like that, 330,000 feet when I last looked. So, you know, it was a mind-blowing experience, it really was. Absolutely an awesome thing.
Melville even joked that he released a packet of M&Ms in the cockpit just to watch them float. But the wild rotations had been a concern to the ground crew, and Rutan said the data would be analyzed and the problem would be fixed for the next generation of spacecraft that would be built for space tourists. Spaceship One went on to make 2 successful flights in the X Prize competition, claiming the $10 million prize and writing itself into the record books. Rutan said the project had delivered remarkable results.
And how pleased I am that we have a ship that can not only go to space, but it's the first time that a winged vehicle that can make this beautiful landing on a runway, it's the first time that a winged vehicle can have a carefree re-entry. And that is an enormous thing for safety.
Before long, Rutan announced he had joined forces with another entrepreneur, Virgin Group founder Richard Branson. In Branson, Rutan found someone equally enthusiastic and visionary, and most importantly, with an eye for marketing opportunities. The pair told the world that the Virgin Group planned to offer passenger space flights aboard rockets based on Spaceship One by 2007. The spacecraft would fly to 110 kilometers, a little higher than the original prototype, and passengers would be able to experience a short period of weightlessness. It would then fold its wings to re-enter the atmosphere and return them to the original position to glide down onto the runway. A businessman who delighted in pushing the envelope, Branson threw all his marketing muscle at the project, pitching it as an opportunity for everyday people to experience the excitement of space travel.
Well, hello, I'm Richard Branson. We've been fortunate enough to have achieved some pretty extraordinary things at Virgin over the years, but perhaps none quite as amazing as what you'll see in the next few minutes. Virgin Galactic is on its way to becoming the world's first commercial space line. Our suborbital space trips promise to be the most intense and wonderful experiences that our passengers have ever had.
About the size of a corporate Gulfstream jet, Spaceship Two can accommodate 6 tourists and 2 crew members. Branson's Virgin Group is financing the project's $100 million first phase, and Branson expects test flights to begin in December 2009. After about 100 test flights, the first commercial flight is scheduled to leave Earth in 2011. Virgin Galactic plans to fly the first passengers for $200,000 apiece, with the first leaving from California's Mojave Desert and later flights from a proposed spaceport in New Mexico. Speaking at the annual International Space Development Conference in Los Angeles about his dream for space travel beyond just suborbital flight, Rutan said he wants to go further than the edge of the Earth.
My goal, and everybody, you know, when you get as old as I am and have all this gray hair and you get 60, you tend to think of, wow, what I'm going to do with the rest of my life. What would I like to see happen? What would I like to see occur? And I've got something pretty ambitious, and that is I do want to go to the moon in my lifetime. And I want to see affordable travel to the moon in my lifetime.
Virgin Galactic is also looking at possible future spaceports in the United Arab Emirates, Australia, Scotland, or Sweden. The maiden flight will carry Branson and Rutan, among others. According to Virgin Galactic President Will Whitehorn, some important input on the design of Spaceship Two has come from the soon-to-be space tourists themselves. More than 50,000 people have shown interest in becoming space tourists, and Virgin Galactic says it will be flying people within the next 3 years.
Burt Rutan's prototype, Spaceship One, worked. So that hurdle was crossed. That was one of the big hurdles. Designing Spaceship Two has been relatively easy. We've had a lot of input from potential customers, so we've been able to design on the basis of what people want. And the most important thing that people want is to have a lot of space so they can move around weightless in the cabin and experience not only seeing the Earth, seeing the biosphere, the curvature, the atmosphere, seeing space, but also move around.
And Rutan has a message for those who have called his vision crazy.
Usually the wacky people have the breakthroughs. The smart people don't.
So far, Virgin Galactic has collected $31 million in deposits from people determined to secure a spot on the first 100 flights. The company expects the $200,000 cost to gradually come down over the years, opening the experience to a far wider range of people. But getting Spaceship Two into the air has not been all smooth sailing. In July 2007, 3 people were killed and 3 seriously injured when an explosion occurred at Mojave Airport during a fuel flow test, sending shrapnel flying through the air. The test involved filling the oxidizer tank with 4,500 kilograms of nitrous oxide, followed by a 15-second cold flow injector test. But the company has continued to move the project forward, albeit a few years behind schedule, certain that even with the risks involved, the magic of space travel will guarantee full flights.
We're designing our spacecraft so that each of our passengers will have the room and the freedom to enjoy the amazing sensation of weightlessness.
The system will also be large enough to allow those individuals to really experience weightlessness, to really experience the beauty of the curvature of the Earth, and to be able to see that from any angle in the ship that they're at. And also to be able to experience the real feeling of the power of flight into space.
While you're up there, you got 4 to 5 minutes of zero-G and an enjoyment of an environment you've never experienced before. You've maybe seen it on covers of magazines, and now you're experiencing it firsthand.
Right.
It's a delight. It's a wonder. And
I'm sure with everybody being loose in there, they'll be letting go M&Ms and taking pictures of each other. And I mean, it'll just be the most fabulous thing that you could imagine.
As one of the fortunate few to have experienced space travel, Melville's enthusiasm knows no bounds.
Before you ignite it, you're indicating 140 knots or so. And within 10 seconds or 11 seconds, you're supersonic. So, you get 3 Gs on your back instantly when it lights. And boy, that first 10 seconds is about the most dynamic flying I've ever done.
this wave of energy flows through the vehicle, and it's eye-watering.
It is eye-watering. When you look out the window and you see the curvature of the Earth, and you can see the edge, along the edge of the Earth, you can see this thin blue line that is the atmosphere, and the colors and the textures on the ground, and it's a mind-blowing thing to see. It really is. I mean, I'm sure everybody who's been in the shuttle or on the space station knows the same thing, but I'd never seen that before, and it really was a remarkable experience.
Rutan says the ship's advanced technology reduces the risk of accidents.
Spaceship One has a unique feathering configuration. It can come into the atmosphere at any angle and it'll straighten itself out without the pilot having to fly that or without a computer having to do it. And this is the first horizontal landing, runway landing spacecraft that's ever had this feature, so we're immune to accidents caused by flight control failure during re-entry.
We found a motor to power the Spaceship Two, working with Burt Rutan, which is much more environmentally benign than a solid fuel rocket motor launching from the ground as the shuttle does.
The enormous amount of power that it takes to get a rocket launched from the ground doesn't apply to this system. We're actually going up in an aircraft with very state-of-the-art jet engines. Maybe one day those jet engines will be able to be fueled by renewable jet aviation fuel. But the rocket burn, which is what most people are concerned about in any sort of space access, is very short, and most of it is out of the atmosphere.
At a recent event, the fortunate few who have been guaranteed a seat on one of the first 100 flights gathered to view the progress so far. Some reject the label space tourist, seeing themselves as space pioneers or travelers.
By the time the first astronauts have taken their seats in Spaceship Two, our aim will be to have them fully relaxed and fully trained after a program of 3 intensive days at the spaceport in New Mexico. Most of all, they will feel through this experience that they really have been up there where only 450 people have been over the last 45 years.
Branson says the first flight will be a family affair.
I'll be going to space. What's more, my parents and children will be coming with me.
The public got a glimpse of Virgin Galactic's futuristic aircraft when London's Science Museum mounted an exhibition in 2007. Visitors had the chance to see a mock-up installation of the world's first tourist spaceship. The exhibition emphasized the company's desire to take space travel to the masses, with over 70,000 people from 125 countries already registering their interest in becoming a Virgin Galactic astronaut.
We're going to be unveiling the spaceship at the end of this year, and the first test flights are going to be happening 2008 and first commercial flights 2009. So it's really beginning to happen.
5, 4, 3, 2, 1.
Virgin Galactic's prediction proved to be a tad optimistic, as the company abandoned plans to use the Spaceship One prototype as a model when research indicated that passengers wanted the opportunity to float around the cabin, even if it was only for a few minutes. The new, larger Spaceship Two design was drawn up, putting the company back a couple of years, but providing a more attractive commercial proposition. And the company's plans have certainly generated excitement around the world. More than 95% of the 200 initial applicants have passed 6 to 8G centrifuge tests and are set to be the first people to take a trip on the first commercial space flights.
And we have 200 people who have committed to fly. So yeah, and that's quite something considering that we haven't actually unveiled the real spaceship yet, and we certainly know that more people will be signing up after they see the spaceship as well.
The requirements of a larger aircraft meant the launch vehicle also required a revamp. But the bigger scale of VMS Eve, almost double the size of the original aircraft, means the company can offer space for scientific research, something that could provide an additional stream of income. In 2002, consultancy Futron predicted that by 2021, more than 15,000 passengers could be flying suborbitally every year, generating over $700 million. Virgin Galactic is confident that the company is on track to achieve these numbers, reporting an after-tax profit of £136,400 in its latest accounts.
We're planning to fly 500 people in the first year of operations and 50,000 in the next 10 years. And what our real aim is to try and bring space travel to everyone so that everyone has that opportunity.
After listening to customer feedback, Virgin has drawn up plans to incorporate roller coaster-type bars in front of the seats rather than shoulder harnesses and seat belts, This will make it easier for passengers to push themselves out of their seats and enjoy weightlessness. Rutan has even commented that people can bring their pets with them into space if they want to. They will also have the option of launching from one site, such as the Mojave Desert, and landing in another, or from the ocean, fly over the mountains and land in the desert. One of the keys to future space travel is enthusing the astronauts and space engineers of the future. In 2008, Mission Virgin Galactic was launched in London to inspire children about space travel and get them more involved both in and out of the classroom. Designed with the backing of education experts, the scheme fits into the national curriculum and aims to educate new generations about the possibilities of science, maths and technology in a fun and exciting way.
The best of these ideas is going to win one of these teams a chance to go and see a space launch in the Mojave Desert in the United States. And long term, although we can't promise this at the moment, should the test flying program succeed, which we believe it will over the next couple of years, eventually some of these teams, when they're older, we're going to keep their names and they're going to be able to re-enter, we hope, to get the chance to actually fly to space in the future.
The project challenges students aged 11 to 14 to design a marketable product that demonstrates one or more of the science, technology or engineering principles used in the Virgin Galactic space tourism programs. And it appears to be a hit with its target market.
It's Final Frontier Space, isn't it? It's very interesting. You want to always know what's going to be out there, and I often sat there wondering what's going to happen next and things like that, so Virgin Galactic's going to be a change for it all.
There's plenty of enthusiasm for the concept.
I think it's the beginning of something. It's like, I'd say it's like VCRs. You know, they started out really expensive, and the people who really wanted to make this happen will pay the money to do it, and then it'll come down in price to make it accessible to everybody.
The idea can be anything from a toy to a high-tech gadget. Judges are looking for creativity and innovation with a fantastic prize for the winners. The competition is now underway in British schools, with plans to extend it across the rest of the world in coming years. Mission Virgin Galactic hopes the birth of a new era in space travel will help young people in British schools realize the exciting realities that are achieved through expertise in science and technology. But despite the intense interest generated by Virgin's project, the global financial crisis put a dent in the company's plans. In July 2009, Branson was forced to sell about a third of his space travel startup to Abar Investments, a Middle Eastern investment fund.
And I've met people from, I would say, all walks of life, men, women, college professors, older people, younger people. Everybody is ready to pay for a ticket to have a chance to go into space. That by itself, I think, is quite exciting.
The partnership gave the venture an influx of cash at a time when the global recession had dried up funding sources. Abar Investments paid $280 million for the 32% share of the company. The agreement gives the wealthy Persian Gulf Sheikhdom of Abu Dhabi the chance to set up its own spaceflight industry, with Abar planning to build spaceport facilities. The company also committed $100 million to fund a small satellite launch capability. Branson said he wasn't concerned about bringing another partner on board, seeing it as an opportunity to take a slice of an even bigger market.
I never actually think about the investments I do. I think about creating things that I can be proud of, and I think generally if you can create something you can be proud of, it's likely to be successful. And you know, I think there are so many, millions and millions of people who'd love the chance to going into space, and it needed private enterprise to make that possible.
But it's not just space tourists who have the opportunity to experience the joys of zero gravity. Scientists in France are being invited to join a flight offered by the country's space agency that reproduces the same weightlessness as in space in order for them to conduct important research experiments. An Airbus A300 has been converted into a flying laboratory, offering European space scientists ideal conditions in which to carry out research in zero-gravity conditions.
I would tell to a scientist who needs microgravity for research, either he can wait a bit more to go in space by flying first on this Airbus, or if they don't need to go in space for their research because 22 seconds is enough 30 to 40 times in a given flight, then you come to the zero-G Airbus and they can produce science and publish in good magazines without the need to go in space.
Students from across Europe and from prestigious universities gathered in Bordeaux to prepare and install their experiments on the zero-G Airbus. Like an elevator, a spacecraft in orbit keeps falling, but over the horizon, following the Earth's curvature. The zero-gravity flights take off and ascend at a sharp 45-degree angle, reaching a certain altitude, and then free-falling over an arc in the Earth's curvature. Novespace, a unit of France's CNES space agency and the 17-nation European Space Agency, claims to be leading the field in scientific deployment with the converted Airbus A300 jetliner. To achieve a point of weightlessness, French test pilots fly the Airbus along a series of parabolic arcs in an air corridor over the Atlantic, resembling an 8,000-foot-high roller coaster. Passengers feel twice their normal weight during the steep 45-degree climb, but experience 22 seconds of weightlessness, floating as the plane flies along the crest of the arc when the engine power is sharply reduced. Dieter Volkmann studies how gravity changes impact the growth of plants. The latest experiments show that gravity-changing conditions generate strong and rapid responses in plants' roots, with changes in oxygen consumption and even changes in the plant's genes. This, in the long run, could allow the growing of plants in the International Space Station and the cultivation of plants on other planets.
Maybe one day we will be able to grow plants on different other planets or on Mars, for example. But we know how they behave under microgravity and also under lower gravity. Like Mars has 0.7 gravity of our Earth and so on. So we need lots of information about the communication between plants in the plant itself and how they survive under a stressful situation.
Brief doses of weightlessness without going into space have been available for decades on specially converted airliners such as NASA's Vomit Comet, which trained a generation of American astronauts and was used to film Apollo 13. Over in England, British scientists worked on developing a solar-powered plane that could become a cheap alternative to space satellites. Plans were drawn up to take Zephyr 3 to the edge of space by a balloon. If successful, scientists hope the technology could significantly lower the cost of collecting image and surveillance data from space.
The thing we're really looking for is that if it's, we can keep it up high and we can keep power through the sun and then recharge batteries to keep it in the air at night. And we can keep the aircraft up there nearly continually, certainly for long durations. That means the costs and the risks of launching and landing and operating aircraft at lower altitudes where the civil air traffic is flying are mitigated.
A recent British exhibition also focused on the issue of aviation and the environment, asking visitors to consider the growing impact flying has on the planet.
The impact is, it's not a lot at the moment compared to things like road travel. What's important is that the impact is growing rapidly, really quite considerably. Passenger numbers are set to double in the next 20 years, so clearly something has to be done, and it's certainly something the aviation industry and scientists and engineers all around the country and around the world are working on very hard to try and reduce this impact. And there's lots of technologies that we showcase in the exhibition that you can come and see, different plane designs, new materials, new fuels that will help to reduce the impact of climate change. But obviously this technology can only go so far, and that's where you have to consider that for individuals, your flying habits can make up a large percentage of your personal carbon footprint, so maybe it's something, we're not asking people to give up flying, I think that's unrealistic, but maybe to think about what you do and how often you fly.
The exhibition invited visitors to calculate their carbon footprint, according to how often they travel by air and how far. It also offered some examples of technological solutions in the pipeline, enabling planes of the future to have less impact on the environment. One aircraft design was based on blending the wings and engines with the fuselage to reduce friction and increase fuel efficiency. The body was made from lightweight composites like plastic, which can be polished to a mirror finish. Another design showed the return of propellers allied to jet engines, popular before pure jet engines. These new propeller blades were strong despite being made from lightweight composites. They contra-rotate to reduce noise. Carbon emissions from conventional jet engine exhausts can be sucked up and eliminated by a filter collar designed to be retrofitted to existing engines. But don't expect to see this technology tomorrow.
There's a long step change in how long it takes to introduce new aircraft, so things being designed now in labs across the country we won't be seeing for 6-7 years, and that's technology we have now. But in terms of longer lead times, in maybe 20 years' time, we could be seeing really quite different plane shapes, and actually very different from the ones we see today. There's a model here of something called a blended wing body aircraft, which is a lot more aerodynamic, and that's something we could be seeing by maybe 2030.
With environmental awareness growing throughout the world, the aviation business is being forced to take stock of its practices and consider greener alternatives. With air travel contributing to between 3 and 3.5% of all carbon emissions, there is debate over whether higher taxes to offset the emissions or better designed aircraft that produce less emissions are the answer. Some argue that higher taxes would lock lower income travelers out of the aviation market, restricting it to elite or business travelers. Others say that airlines should be an integral part of any emission trading scheme set up by the world's governments. Green technology is also appearing at airports around the world. Heathrow has unveiled a personal rapid transit system, or PRT, that will replace buses between Heathrow's business car park and its new 5th passenger terminal. Testing is underway before 18 four-seater driverless pods begin carrying passengers over a 3.5-kilometer steel and concrete elevated track when services start. The $50 million project is the first commercial PRT system in the world and will transform the way passengers travel around the world's busiest international airport. The designers, Advanced Transport Systems, say the vehicles are typically 50% more energy efficient than traditional buses.
We no longer can solve the problems that we have at Heathrow. It's very congested, it's a very small area, in traditional ways anymore. For instance, putting more buses on the roads just means the roads get even more congested and passenger travel times are reduced. So we have to look at different ways of solving problems, and this was one of them.
The pods are guided along the track by laser sensors which are embedded in the vehicle. They are powered by batteries which are recharged as necessary when the vehicles are stationary. Emissions from the vehicles should amount to around half of those produced by a train or bus. And unlike public transport, passengers will not have to share the space with strangers or wait while the vehicle makes other stops. Boarding passengers use a touch screen to choose their destination, either Terminal 5 or one of its 2 car parks, and the vehicle will take them straight there. The access points and destinations chosen by passengers are a series of offline stations which will be distributed around the network like bus stops or taxi ranks.
It's a good solution because it takes traffic off the road. It's not running down the same roadways as the buses and traffic. It's environmentally sensitive, sustainable, and it provides a more rapid and, in some ways, fun way of moving about airports.
When the passenger selects a destination, the central control system responds to this request by immediately allocating a vehicle on the required path and timing for that journey. The central control system also ensures that empty vehicles are sent where they are needed to meet passenger demand.
Its environmental friendliness comes from the fact that it uses far less power than any other method of transport. And the reason for that is it only uses power on demand. It doesn't have powered tracks. The vehicles are battery powered, and they only move when passengers ask to use them.
Simulations demonstrate that waiting times are negligible, averaging around 12 seconds, with 95% of passengers served in less than 1 minute. The vehicles automatically take the passenger to the desired destination, traveling non-stop along the best available route at speeds of up to 25 miles per hour. As a result, typical passenger times are reduced on average by 60% per journey, and travel is more reliable, predictable, and congestion-free. The cars can carry up to 4 people and have ample space for luggage. The system will be monitored for a year, and if it is considered a success, the network will be increased to take in the whole airport and some of the local area. Another area where aviation can make a difference to the environment is in fuel technology. During the past few years, energy companies have been putting greater effort into researching biofuels. One such project has seen Shell working with Iogen Energy Corporation in Canada to convert waste straw, corn stalks and corn cobs into sugar. This is fermented to produce beer, which is then distilled into pure alcohol, ethanol. When mixed with gasoline, the substance becomes a transportation fuel, cutting the carbon emissions of vehicles by up to 90%. Unlike some biofuels, which use food as a fuel source, the straw and corn products are materials that would otherwise be left to rot in farmers' fields. Shell believes biofuels could grow from just 1% of the world's transport fuel to as much as 10% in the next few decades. The aviation industry is keeping a close eye on developments in the auto industry. And in 2008, Branson's Virgin Group successfully flew a Virgin Atlantic Jumbo from London to Amsterdam using fuel derived from Brazilian babusu nuts and coconuts. The following year, it was the turn of the Japanese to showcase biofuels in aviation. Japan Airlines became the first Asian carrier to fly using a biofuel made from 50% kerosene and a mix of mostly camelina, jatropha and algae. Camelina, a second-generation feedstock also known as false flax, has a high oil content and can grow in rotation with wheat and cereal crops in moderate climates in the US, Northern Europe and Central Asia. Tom Todaro, CEO of Sustainable Oils, the Seattle-based camelina provider for the JAL test, says the biofuel is renewable and by itself produces no harmful carbon dioxide emissions.
The primary goal of this is to show sustainability, energy independence by region, and a carbon offset that allows people to feel comfortable that when they're flying through the air, they're not heating up the earth.
Aircraft manufacturer Boeing and engine maker Pratt & Whitney are also part of the development and fuel testing process, which seeks to confirm operational performance and commercial potential. Boeing says it expects biofuel to be used on commercial flights within 3 to 5 years. The JAL demo flight featured a single engine using biofuel with performance tests including quick accelerations and decelerations, shutdowns and restarting, while 3 other engines used traditional jet fuel. Key to further industry use will be securing additional camelina acreage, with expectations that up to 200 million gallons of eco-friendly fuel will be available by 2014. A ground-based pre-flight test was conducted the day before the flight to ensure that the number 3 engine functioned normally using the biofuel traditional Jet A fuel blend.
Engine operating normally, completely normally. So we do not have any doubt to use biofuel for future.
The airline industry was rocked by soaring energy prices in 2008, underlining the need for price-competitive alternatives that are environmentally friendly. Prices have come down significantly since records hit last July, and Sustainable Oils Todaro says the cost advantages are clear if oil rises to $70 a barrel again. Little water or nitrogen is needed to grow camelina, and it can be grown in poorer soils than most food crops, making it an ideal fuel source. The drop-in camelina biofuel blended with jet fuel by Honeywell's UOP using hydroprocessing technology can be used in all aircraft engines. But UOP's Renewable Energy and Chemicals General Manager Jennifer Holmgren says no carrier will go green if it doesn't make financial sense.
The reality is that nobody's really going to pay more just because this is green. So the only way for this to be really sustainable on an economic basis is to be cost competitive with jet fuel produced from petroleum.
And with tests indicating that biofuels can be more efficient petrol fuels in flight, it seems likely that green will be the most cost-effective way forward for the aviation industry, as well as the most sustainable. Well, that brings us to the end of the amazing world of aircraft. And a century of aviation has certainly shown the world some amazing feats. The first decade of flight brought us the genius of two brothers from Midwestern America who engineered the world's first powered flight and flew themselves into the history books. The Wright brothers paved the way for pioneers such as Louis Blériot and Harriet Quimby, who took to the skies in astonishingly flimsy contraptions. Next came the reckless barnstormers and the record breakers. Forged by the fires of World War I, these daring men, and a few women, brought aviation to the masses and opened up the world. From Charles Lindbergh to Amelia Earhart, they captured the headlines and found international fame. The aircraft of the era saw designers pushing the boundaries of aeronautical technology, experimenting with radical designs and concepts. The Bonnie Gull was an example of a less successful experiment, sadly taking its maker to his doom. While the aeroplanes of Anthony Fokker became classics of their time, spurring on the development of airlines. Airships experienced glory days between the wars, their majestic shapes gliding across the world. But the Hindenburg disaster marked the end of their era, and aeroplanes won the race to provide airline transport. The early days of airline travel were for a fortunate few as costs were high, but they were also fraught with danger, tragic accidents an all too common occurrence. With landing grounds in short supply, amphibious aircraft increased in popularity. Polar adventurers such as Richard Byrd tested the boundaries of the world, flying seaplanes into some of the planet's most inhospitable places. And airlines commissioned giant flying boats to deliver luxury travel in the style of cruise ships. The Second World War marked another turning point for aircraft design, with Briton Frank Whittle and German Hans von Ohain independently developing jet aircraft. Whittle's success put Britain at the forefront of the industry, and the age of the jet airliner was upon the world. The development of large airliners brought air travel to the masses, and saw intense rivalry between British companies like Avro and de Havilland and their American counterparts, MacDonald Douglas and Boeing. The world began to shrink as the great airlines of the world set up highways in the sky, linking the furthermost parts of the globe. From British flagship BOAC to Australia's Qantas and the great Pan American, airlines established themselves as icons in their own right. The famous people who arrived at airports around the world enhanced the glamour associated with flying. And with ticket prices continuing to fall, even not so famous people could leave behind their humdrum lives and fly direct to some of the most famous places on the planet. Airports evolved from muddy fields equipped with only tents to paved runways, custom-built terminal buildings and control towers. Cabin crew also evolved from waiter-style stewards to would-be beauty queens. Fashion rather than safety seemed to be the primary concern. Supersonic flights left the realm of fiction and became reality in the 1960s, with the Europeans battling it out with the Americans to produce a supersonic jetliner. The Europeans triumphed with the Concorde, a masterpiece of design and engineering with a very high price tag. Left in the dust, the American Boeing design was later abandoned completely. But Boeing triumphed in the battle of the subsonic airliners, producing the 737 to become the world's most popular airliner, and the innovative 747 jumbo jet. In retaliation, the Europeans set up Airbus Industries and developed their own jetliners, going head-to-head with Boeing for the mass aviation market. But as the skies became ever more crowded and aviation traffic increased, so did the level of catastrophic accidents. The world mourned the thousands lost in plane crashes around the world, including the world's worst aviation disaster at Tenerife. Two 747 jumbos collided on the runway, incinerating one aircraft and killing most occupants of the other. Although flying had become commonplace by the 1980s, there were still adventurers to be found. Steve Fawcett embraced ballooning and gliding, as well as powered flight in his record attempts. Richard Branson used his exploits to market his airline, Virgin Atlantic. Then came the Battle of the Titans, the Airbus A380 versus the Boeing 787 Dreamliner. Despite a glitzy launch and plenty of publicity, the Boeing design failed to make the grade in the expected time frame, leaving the A380 the undisputed winner. So that's it for the amazing world of aircraft. Next time you're cruising 30,000 feet above the ground, spare a thought for the men and women who made aviation possible, the dreamers and risk-takers who refused to be constrained by convention, and launched the world on the adventure of flight.